gee, how many tails is it? I like to draw a picture first because then that tells me how many tails I've got and stuff like that. So this is less than. Where is that going to be, the left side or the right side? Left side, less than is on the left. So this is going to be one-tailed. What's my degrees of freedom? It's a mean, I got to count them. Well, yeah. Degrees of freedom is going to be 12 of them minus 1. So there's 12 of these. So it's 11. And my alpha is 0.05, 0.01. So then I'm going to bust out my little handy dandy t-table. One tail test, that's the bottom row of a 0.01. So it's the very middle column. Down to 11, 2.718. Except it's left-tailed, so it is negative 2.718. Great. Next step, you find my test stat. Let's see, it's my x bar, 523.1, minus what I had in my claim. My claim is 515. Divided by s, 78.6 over square root of n. N is 12. Good. So then this is going to be 8.1 over, what's the bottom number? 22.7. And then you end up with 0.356. Great. That's somewhere over here, totally in the do not reject region. So that's that. Oh, and I should label that test stat. So I mean, since this is what the shading is, I'm kind of in good shape. But still, it's good to label it. Never hurts to label it. And so that's good news. That means that am I going to reject or not reject? No. Yep. Do not reject. It's not in the rejection region over here. It's not unusual. Quite usual. Do not reject H naught. And then my last step will be that, yep, there's not enough evidence. So remember, when this is not, that's not two. The knots go together. They're both knots or they aren't. Or neither one is, right? So not enough evidence to, yep, H1 is my claim, so I'm going to use support here. Claim that her students scored, let's just say below average, that's close enough. Good? Yeah.
Will we get the same amount of points on the exam if we just copy the names like from page 1 or page 1?
Yes, absolutely. Perfect. Yes. Yes, I'm perfectly happy whether you whether you paraphrase it or whether you write it verbatim, same thing. You just have to write it. But I'm just writing what the bare minimum what you need to have. All right, great. Do you folks need a minute to confer with their neighbors about this? No, okay. All right. Then moving on. Magic formula sheet. If anybody did not get a magic formula sheet, come get one from me during the break. Make sure that you put that note in there about making the freedom and -1. Alina, you weren't here. You need one. Everybody else I think was here. Okay. Where did Alina go? Alina's here, right? Oh, maybe not. She just left? Oh, no, I'm sorry. She was here last class. My bad. She came. She's in this class, but she came to the class. All right, so you said 83, 84 to do stuff. Remember, if it's an interval, that's for confidence intervals. The ends of the word test, it's for a hypothesis test. T interval, T, mean Mr. T. T interval, that's for means. One proportion, prop Z, that's for proportions. If it has a 2 in front of it, that's for chapter 9, which we're going to get to a little later on. The intervals are actually less useful for you because I'm going to make you find the margin of error anyway, so yeah, it's just easy to compute it. The tests, Ryan, so the t-test is a test for a mean. 1 prop z test is a test for a proportion. Good, again, no big surprises there. We went over those earlier. And now we're going to talk about chapter 9. So remember, confidence intervals, that's chapter 7. Hypothesis tests, that's chapter 8. Now we're on chapter 9, which is 2 sample tests. So a lot of times we're comparing, like for example, Nathan, you might compare, someone who got the COVID vaccine and someone who didn't, right? So Pfizer, they want to know, so they inject a whole bunch of people with their vaccine, they inject a whole bunch of people with a placebo, and then they see how they fare over the long run, and compare the 2 groups. So that's what we're kind of looking at here. All right, the null hypothesis is always equal. In this case, P1 equals P2. You can also write it as P1 minus P2 equals 0, because if they equal each other, then when you subtract them, you should get 0. We also had to find the P bar. And that's when you pool the 2 groups together into one big group. So you take the total number of successes from the first group plus the total number of successes from the second group, and divide by your grand total of people, your N1 plus your N2. Q bar is just 1 minus P bar. Okay. The test stat is the other thing that's unusual or different. And remember, since P1 minus P2, those should be equal, so when you subtract them, you should get 0. It's really just this part here. And I think in your on your notes, you have the equivalent, which is square root of they subtracted out the P bar, Q bar in front, and multiplied by 1 over N1 plus 1 over N2. You can do it either way. If you're going to do it this way, then what you want to do is you want to start from the inside out. Do the 1 over N1 plus 1 over N2 first, and then multiply by P bar and Q bar. Enter, and then take the square root. I can do one of those if you folks want later on, or momentarily. So this one actually belongs lower. So what I want to do next is I want to do. We finished lab problem 2, correct?
Yeah.
Great. So we're just going to do quiz problem number, I do want to point one thing out, which is this formula that we're doing, it's based upon the general, all the other z-scores, right? You take your observed value minus your expected value divided by the standard deviation. So all of them are really just that. It's your observed value minus your expected value divided by the standard deviation. Right? This is the same thing. My observed value, the observed difference is p hat 1 minus p hat 2. Minus the expected value, which is a difference of 0, divided by the standard deviation. When you subtract 2 standard deviations. So it's not really, it's not a new formula. It's not a different formula. It's the same old formula. It's just it's a different. It changed based upon what your expected value is, what your observed value is, and what your standard deviation is. All right. I feel like we should talk about this briefly, and then I should let you go. Actually, I kind of talked about it already a little bit, didn't I? So I did mention the fact that you have a p hat 1 and a p hat 2 you need to find. You also need to find p bar. So p hat 1, this is our first group. So p hat 1 is going to be 12 out of 48. P hat 2 is going to be 27 out of 43. And you should give me how many decimal places? 3. I need 3 decimals. So the first one is p hat 1 is 0.261, and P2 is 628. And then P bar is going to be, you combine them. 12 plus 27 successes out of 46 plus 43 total, and you will get 438, which means my Q bar is 0.562. Good? All right. Now remember, we're trying to say, what's the claim? The claim is that money in large denominations, in other words, P hat 1, or P1 is less likely than smaller. So large denominations is less likely than smaller. Less likely should be, is that going to be greater than, less than, not equal to, or not equal to? Less than. So that's my claim. Claim is that P1 is less than P2. All right, do folks need just another 3 minutes to finish this up? Let's do it this way. We're going to take a break. If you have not finished it up, then get it done now, because you should have it done already. But we will come back at 56 after. So 58 after. We'll come back at 6:08. 6:10, fine. I'll give you 2 minutes. Work on it now for 2 minutes at least. And if you haven't finished it yet, and then take a break.